Hello students, how are you? I hope you are doing well. In this video, I have come up with two questions from electrostatics and two questions from current electricity, which were asked in the second shift, 25th January 2023 JEE mains. So this coming to the first question, a point charge, as you can see, point charge of 10 microcoulomb is placed at the origin. At what location on the x-axis should a point charge of 40 microcoulomb be placed so that the net electric field is zero? It's a very simple question, students. You have the x-axis here. So at x equal to 0, you have a 10 microcoulomb charge, and you are asked to find the position of the 40 microcoulomb charge, so that electric field is at 2 cm is 0. So suppose this is a point at 2 centimeter. We want electric field to be 0 here. Now as you can see that electric field due to this charge will be in this direction. I'll take this as Q1, so I'll write this as E1. So naturally, in order to have zero electric field, the other component, the field due to the other charge must be opposite to this. So that certainly the charge must be placed somewhere here to the right of point P. So we have to find x. So I'll do one thing. I'll take this as x dash. Okay. So if net field is zero, net field at point P is zero. That means what? Both the electric fields due to the two charges must be equal and opposite to each other. So E1 will be K Q1 by R square. Similarly, E2 will be K Q2 by X dash square. Okay. So if you cross multiply this, you'll get X dash as equal to, we'll extract the square root. So you'll get 4 cm. 1 0 gets cancelled, k gets cancelled, extract the square root. So x dash will be 2 into 2. So this is coming out to be 4 cm. So the required value of x, that is position of Q2, will be 2 plus 4, that is 6 centimeters. So first option is the correct answer. Then moving on to the next question. A capacitor has capacitance of 5 microfarad when its parallel plates are separated by air medium of thickness d. So let us draw the diagram. Separation between them is d. This is air as the medium between the plates. So the capacitance is given as 5 microfarad, which is actually A epsilon 0 by d. A epsilon 0 by d. Then the next situation, it is given that it is filled with a dielectric, but not completely. Not completely. Half, only half. Okay. So thickness will be d by 2, having an area equal to that of its thickness d by 2. So the electric constant is K. So the new capacitance will be A epsilon 0 upon d minus t into 1 minus 1 by K. You are supposed to memorize this result, students. So here t is d by 2. So I'll open this bracket, d minus d by 2 plus d by 2 into k. K is 1.5. I am going to write 1.5 as 3 by 2. So 2 gets cancelled. Then we are left with A epsilon 0 upon d by 2 plus d by 3. That is 6 A epsilon 0 by 5D. But as you know, A epsilon 0 by D is already given as 5 macro. So when we replace A epsilon 0 by D with 5 macro, 5 gets cancelled here. 5 gets cancelled and we are left with 6 microfarad. So the correct answer is 6 microfarad. Then moving on to the next question. The resistance of a wire is 5 ohms. Its new resistance in ohms, if stretched to 5 times of its original length, will be. Now for a prismoidal structure, resistance is given by rho L by A, resistance between the end faces. Since here the same wire is stretched, so the volume remains constant and we have complete information regarding the length, the new length. So we can replace the area with volume by length. For any prism, volume is equal to cross section area into length. So we have rho L square by V. So here you can see resistance varies directly as square of the length because rho and V remains constant here. So let us find the factor of change for R by putting the factor of change of L here. So L has been increased to 5 times. So the factor of change for L is 5. So the factor of change for R will be 25. So the new resistance is equal to original resistance multiplied by factor of change. Since the original resistance is 5, so substituting the value, you get 125 ohm as the answer. So correct option is the third option. Then moving on to the next question. Two cells are connected between points A and B as shown. Cell 1 has EMF this and internal resistance, cell 2 has EMF this and external resistance R of 4 ohm is connected across A and B, current flowing through R. So this question can simply be solved, students, by replacing this system with a single equivalent cell. You can see both the cells are in parallel. So the formula says if E is E equivalent, EMF of the equivalent is this equivalent cell, then the formula is this 1 by R1 plus 1 by R2 plus dot 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 is equal to E1 by R1 plus E2 by R2 dot dot dot. This is the formula. So we are going to replace this with the equivalent cell. So before we start, let us see. R1 is 3 ohm and R2 is 6 ohm. E1, I'll take this as 12, so 12 by 3. Remember students, this is the negative terminal. You can see the negative terminal is connected to this point. So I'll take this as plus. So I'll put this as minus 6 upon R2. Internal resistance is never negative. Resistance is never negative. So this will be E equivalent 1 by 3 plus 1 by 6. You take the LCM and you have, or take 1 by 3 common, 1 plus half is 3 by 2. This will be 4 minus 1, that is 3. So the equivalent cell EMF will be 6 volt. So if we draw the circuit diagram will be like this. 6 volt is the equivalent one. And coming to equivalent resistance, since the resistances are in parallel, so use the formula product upon sum. Product upon sum. Product upon sum. So you get 2 ohm. So this is 2 ohm. So it is connected across an external resistance R is equal to 4 ohm. 4 ohm. So in a simple loop, as you can see, this is a simple loop. In a simple loop, you can calculate the current as sigma EMFs upon sigma Rs. Algebraic sum of all the EMFs included in the circuit divided by the sum of resistors. So only one cell is there, so 6 volt. Total resistance is 4 plus 2, that is 6 ohm. So current is 1 ampere. So the answer is 1 ampere. So that's all in this video, students. I hope you are liking my videos. Kindly subscribe to my channel and hit the like button. Thank you so much.